my entire screen. Share. Camera. Okay, can everyone see and hear me?
Yes.
Okay, thank you. All right, so this is lesson 27, the equation of a linear relationship. If you remember back, not last week, but the week before, that's kind of how we ended too, with the general equation y equals mx plus b, where m is our rate of change or our slope number. So how steep our line's gonna end up being. And b is our initial value where it starts on the vertical axis. Or last week it was on the y-axis. So today we're gonna look at it from a actual real life situation point of view, okay? So our learning goal is to determine the rate of change m and the initial value b and the equation of a linear relationship from a table of values and from a graph. So our first example, Brent is looking to rent a Skidoo. He finds a rental place that charges a $50 deposit plus $15 per hour of use. So just using common sense here, we should be able to complete this table of values. So if he doesn't Skidoo for any time at all, he still has to pay $50 because there's a $50 deposit. So at time 0, he has to pay $50. And then if he uses the Skidoo for 1 hour on top of that, he has to pay $15 more. So we'd have to add 15 here. And that would give us $65 if he uses it for 1 hour. If he uses it for 2 hours, he has to pay another $15, which would give him it would cost $80 for 2 hours. And then for another hour, he'd have to add on another $15, which would be $95. And then for another hour, another $15, which would be $110. So there's our table of values, and we did it just using the common sense that we had to pay a $50 deposit and then plus $15 for each hour. And then let's draw our graph from this. So we know that the first column always represents the horizontal axis. So here's our horizontal axis, time. And we have to fit the numbers from 0 to 4. So I'm going to do every 2 squares is 1 just to spread it out a bit. Remember, the scale has to be consistent. So we can fit from 0 hours to 5 hours along the bottom if we do every 2 squares is 1. And then we know that our vertical axis is always in our second column. And we have to hit fit from 0 up to 110. So it looks, I think 10s will work. So I could do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. I probably could have done 5s, but I might not have fit it all the way. Just go up to 120 here. Okay, so there is our scales, and C represents, this purple one represents total cost in dollars. And this is time in hours. And then we have to remember that this row, the first row, represents the point, 0, and 50. And remember our ordered pairs? It's always the horizontal one first and then the vertical one, like X and Y, except for in this case, it's T and C, but same thing. So I don't go I stay at 0 and then I go up to 50. And that's this point done. And then 1 and 65. So 160. And if this is 70 and this is 60, then 65 is going to be halfway into that square, like that. And then our third row is going to represent 2 and 80. So over to 2 for time, and then up to 80. And the next row is going to represent 3 and 95, which is halfway again. And I want to notice the staircase pattern again that we talked about at the beginning of last week. So our stairs are over 2, up 1.5, over 2, up 0.5, and then 1, so 1.5, over 2, up 1.5. So we would expect to go over 2 and up 1.5, landing there at 110, which we do. So we've got that consistent staircase pattern, which is a hallmark of linear relationships where you always get this staircase happening, where the stairs are all the same. So there's our line. So that was B, graph the relationship, make sure you choose a consistent scale. We did that. From the graph, identify the initial value. So the initial value is where you start. So there's my initial value. I also want to show it to you in the table. So when T is 0, this is my initial value 50 here. So we know B is 50. So my initial value, B is 50. $50 actually. And that means if you rent the Skidoo for 0 hours, it costs you $50. On the graph, when T is 0, C is 50. From the words, the rental place charges a $50 deposit, which you only pay once. So initial value, what you pay initially or at the start, what you pay at the start. Makes sense from the words as well. And then the rate of change. So we know that that's M and we know it's rise over run. We know we can get the rise from the table. It's always the second column differences. And we know the run is always the first column differences. So if we did it from the table, we would get $15 over 1 hour, which is $15 per hour. Also, if we look in our question, it says $15 per hour. So I'd be thinking this is my M. And then for the deposit, I'd be thinking $50 deposit, which I only pay once. This is my B. And then also we want to get it from the graph. So we could make a rate triangle. Maybe I want to go with corners. So I could go from this corner to this corner and make a rate triangle where my rise is 10, 20, 30. And my run is from 2 to 4, which is 2. And if I use rise over run from my graph, I get $30 over 2 hours, which is also $15 per hour. So notice how I could do it from the table and get $15 per hour. I can do it from the graph and get $15 per hour. I can do it from reading the question and get $15 per hour. So whichever way you're most confident with is fine. And then determine the equation of the linear relationship. So one thing that's important to know is all linear relationships have this general equation. And that comes from having a line where this is the y-axis and this is the x-axis, and then there's your line that has an initial value b and some rate of change that you can find from making a rate triangle. So in this question, what we want to do is change over this formula. So our y-axis isn't our y-axis, it's our c-axis. So I'm going to replace y with c, meaning cost. M is a number, it's the number 15. X, in this case, is called the t-axis for us because it represents time. Plus our initial value, which is $50, which we can see on our graph. It's where we start is our B. So our equation is C equals 15t plus 50. And it makes sense because it means you take the number of hours t multiply by 15, that gives you the $15 per hour amount, and then you add on the $50 deposit. Okay, so hopefully that first example has kind of brought back all the stuff we were working on last week. And we're going to do 3 more examples like this, which is the first 2 pages of the lesson. So our next question, Caitlin is just learning to snowboard. Big Mountain charges $40 to rent equipment. You only pay to rent equipment once. So if I was reading this question, I'd be like, that's the B. The B is $40. I'd pick it right out of the question. And $10 per hour. So when I see per, I think M. $10 per hour for lessons. So I'm thinking this must be the M, the rate of change. Represent the relationship between the total cost Y and the number of hours of lessons X using a table of values, a graph, and an equation. So we should be able to fill in our table really easily. For 0 hours, it costs us $40 to rent the equipment before we've even gone snowboarding at all. If we snowboard for 1 hour, we have to add $10 onto that. And then another $10 if we go for another hour. So there's our pattern of adding $10 each time. So we've done our table. Excellent. Now we have to convert this into a graph. So the first column always goes on our horizontal axis. And so 0 is going to be here, and we have to go to 4. So we'll do every 2 squares is 1 again. And then we want to say what this one is. This is X, and it's number of hours. And then this is our vertical axis, total cost. And we're calling it Y. And it would be in dollars. And for costs, we have to get from 0 to 80. 10, 20, 30, 40, 50, 60, 70, 80. Yeah. So I could do 20, 40, 60, 80, 100. So that's still every square is worth 10, 10, 20, 30, 40, 50, 60, 70, 80. Plot my points. So the first row in the table represents 0 horizontally and 40 vertically. So there's my first point. The second row in my table represents 1 and 50. The third row in my table represents 2 and 60. And you should start seeing the staircase, over 2, up 1, over 2, up 1. So I'm going to predict over 2, up 1. And sure enough, 370 is right there. Over 2, up 1, 480 is right there. So there's my line. So we've done a graph. Now we have to do an equation. So our general equation is always y equals mx plus b. Our vertical axis is y, so we just keep it y. Our rate of change is $10 per hour. So we can put it in for m. X is our horizontal variable, so we just leave it x. Plus our initial value, which is, you can see it right here. You can see it beside 0 in the chart. You can see it in the question. It's $40 to rent equipment. And then again, if you didn't see the rate of change in the question, if that didn't jump out to you as the rate of change, you could make a rate triangle and use rise over run. So if I made this my rate triangle, because I like using corners, not halfways. I'm counting by tens here. So this would be $20. And this goes from 1 hour to 3 hours. So that would be 2 hours. And I could do rise over run. $20 over 2 hours is $10 per hour. And I would have my rate there. Or I could use my table. The second column changes my rise. The first column changes my run. And I can see 10 over 1 is going to give me 10, rise over run. So don't feel worried if you can't pick it out of the question yet. You can always get it from rise over run using the table or rise over run using the graph. Okay, our next question. Farmer McDonald sells apples for 25 cents each. The table of values represents the relationship between the total cost C and the number of apples N. Represent this relationship using a graph and an equation. So they already made the table for us. 25 cents each, meaning 25 cents per apple. I'm going to think that that's M. Okay, 25 cents per apple. Each means per apple. But we'll see if we can prove that using our table and our graph. I don't see an initial value. And if you look in the chart, besides zero, if you buy 0 apples, it costs $0. There's no like down payment for a basket or anything. So I'm thinking the initial value is going to end up being 0. So I'm thinking B is 0, but we'll see whether that works out as well. So the first thing we're going to do is we're going to draw our graph. So this is our horizontal axis. And instead of X, we're calling it N. And this is our vertical axis. And instead of Y, we're calling it C. And we have to go from 0 to 16 on our horizontal axis. I think we can use 1. So this is 2, 4. So 1, 2, 3, 4. I'm just showing every second one so it's not as crowded. 8, 12. So 2, 4, 6, 8. Oops, I forgot 10. 10, 11, 12, 13, 14, 15. So 16 is right at the end. And N stands for number of apples. And this is 0 here. And then for C, we've only got to go from 0 to 4. So we might want to do every second square represents 1, 2, 3, 4, 5. And this is total cost in dollars. So we haven't seen one of these very often where the numbers in our first column are bigger than our numbers in our second column, but it can happen. So just remember, the first column always goes on the horizontal axis and the second column always goes on the vertical axis, no matter what the numbers are. So our first row represents the point 0, 0, which is right down here. And that's where we start. So that's our B value. So we were right in thinking that B was $0. Here, so our initial value is 0. The second row is 4 apples and $1. So we go over to 4 and up to 1. The third row is 8 apples and $2. So 8 apples and $2. And you should start seeing your staircase. So we went over 1, 2, 3, 4 squares and up 2. 1, 2, 3, 4, up 2. So I would go 1, 2, 3, 4, up 2 and see if that's right. So that should mean that 12 apples cost $3. And that's right. 12 apples cost $3. And then 16 apples costs $4. And then we should be able to, they should all lie on a straight line. And we've done our graph. So there's our graph. Here's our table. So then we need our equation. And we're going to always start off with the general equation. So y represents our vertical or our y-axis, but we're using the variable c instead. M, there's our rate of change. We haven't calculated it. We guessed that it was 25 cents per apple. We could do our table of values to figure it out. So this is our rise. And our run. 0 to 4 is up 4. 4 to 8 is up 4. 8 to 12 is up 4. So if we do M equals rise over run, our rise is $1 when our run is 4 apples. And if I do 1 divided by 4 on my calculator, I get 0.25 or 25 cents per apple. So I was right in my question. M is 0.25. X is the horizontal variable. So in our case, they're using the letter N instead of the letter X. Plus our initial value B, which was 0, because my line starts at 0. And there's my equation. I don't really need to have the plus 0 because adding 0 doesn't change anything. You can have it, it's not wrong to, but you don't need to have it. That's our equation. And then also remember, if you like the rate triangles to figure out the slope, you could easily have drawn a rate triangle here and seen that this was from 1 to 2, so 1 apple. Sorry, $1, my bad. So 1 to $2, so $1. And then from 4 to 8 is 4 apples. And again, you'd get $1 over 4 apples for your rise and your run. All right, our last question for session 1. The total cost of a large pizza is $10 plus $2.50 per topping. So just to get a large pizza with no toppings is $10. So I'd be thinking, there's my B. Plus $2.50 per topping. So as soon as I see that word per, I'm thinking that's my rate, $2.50 per topping. That's going to be my rate M. Represent the relationship between the total cost C and the number of toppings N using a table of values, a graph, and an equation. So this is the first time maybe we've seen them give us a blank table of values. So we have to know what goes in the first column and what goes in the second column. Okay, so a good rule of thumb is if you've got total cost in your question, it's always in the second column because it always depends on the number in the first column. So N is going to be in our number of toppings is going to be our first column, N. So this is N and this is C. And let's put 0 toppings in case we just want like a plain pizza. And also because we know that if we put no toppings on our pizza, it costs us $10. And then if we put 1 topping on, if we just want a cheese pizza, it's going to cost us $2.50 more. And if we put 2 toppings on our pizza, it'll cost us $2.50 more than that. So that's $15. 3 toppings on, $2.50 more than that.
Hey, Mrs. Northwood, sorry to interrupt. We just lost internet connection.
I did?
No, Nate did.
Nate did? Okay. I'm taping this, so he could always fast forward to the end of it.
Okay.
Okay. Thanks for telling me.
No problem.
And then for 4 toppings, he'd add $2.50 more than that. So that's going to give him $20. So there's our table done. Now we've got to put it onto the graph. So we need to know that the first column is our number of toppings, N. So we only have to go from 0 to 4. So here's our 0. We can put every 2 squares as 1. And then for our total cost, we have to go from 0 to 20. 2, 4, 6, 8. No, it's not going to work. 4, 8, 12, 16, 20 will work. So I guess we could do that. Okay, so we'll make this 4. So we're counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. This is C, which is our total cost in dollars. So our first row represents $0, or sorry, 0 toppings and $10. So there's our initial value. So that's good to know. Let's notice that. There's our initial value. For one topping, it's $12.50. So this is 12. The middle of this square would be 13. So $12.50 is halfway to the middle. Kind of hard to draw there, but that's where it would be. Just above $12. Because the halfway part would be $13. 2 toppings is 15. So here's 14 and 16. 15 is halfway. 3 toppings is $17.50. So 17 is here. So $17.50 is there. And then 4 toppings, finally we have an easy one to plot, is $20. And if you plotted them correctly, here's where we find out they should lie in a line. And they do. Okay, I'm going to practice getting the slope from the graph. So I'm definitely going to join the corners because the other ones are hard, and make a right triangle. And I look at the scale for my rise. 1 square is worth 2. So this is 2, 4, 6, 8, $10. And then I'm going from 0 to 4 toppings, because every 2 squares is 1. So 1, 2, 3, 4 toppings. So if I'm doing rise over run, my rise is $10 and my run is 4 toppings, which gives me $2.50 per topping. 10 divided by 4, which is what we guessed when we read the question, that it was $2.50 per topping. So now I've done my table, I've done my graph, I just have to do my equation. So to do your equation, you start off with the general equation, y equals mx plus b. And instead of the y-axis, should have drawn this in color here. Instead of the y-axis, we've got the c-axis. So instead of y, I'm going to write c. M is our slope number, so it's 250. Instead of our x-axis, this is our n-axis, so I replace x with n. Plus our initial value, which was 10. And again, this equation means the total cost of a pizza is the number of toppings times 250 plus $10 for a plain large. That's how they calculate it. So we've done our equation, our graph, and our table. Okay, I'm gonna exit out of here and pair everybody up. Stop sharing. Stop recording.